I'm here to present a AT Tech Talk video on computer networks in the topic of performance characteristics of selected networks topology in a software, defined networks of queues, testing frameworks, and I'm holding the pin number of 259558610. So here is the introduction. Today I'll be presenting my tech talk on performance characteristics and selected networks based on or testing some frameworks. This topic comes under the subject of computer networks and focuses on how modern programmable networks are analyzed for performance and quality. Software defined networks or SDN is new networking approaches that separates network control from data forwarding, making networks more flexible and easier to manage. In today's world, applications like video streaming, online gaming, cloud computing, and voice call require high quality of service to function smoothly. Quality of service, also known as QoS, quality of a service, refers to the network's ability to provide low delay, high throughput, and reliable data delivery. Network topology plays a major role in deciding how efficiently data travels through the network. Different topologies such as linear, tree, mesh behave differently under a traffic load. By using an SDN based queues testing framework, we can analyze and compare the performance of these topologies in a controlled environment. The goal of this presentation is not just to explain SDN, but to understand how topology selected affects network performance. In this presentation, I'll explain the basis of SDN and the importance of QoS, qualities of services, and the role network topologies observed performance characteristics. Let us begin by understanding it. What is software definition network? Software defined network (SDN). Software defined network, commonly referred as SDN. It's a modern network approach that changes how networks are controlled and managed. In traditional networks, the control plan and data plan are tightly integrated inside network devices like routers and switches. This makes network rigid and difficult to modify when requirements change. SDN solves this problem by separating the control plane from data plane. The control plane is handled by a centralized software component called the SDN controller. Why SDN is needed in modern networks? Modern networks supports a wide range of applications such as video conferencing, cloud servicing, online gaming, and Internet of Things devices. Each of these applications have different performance requirements. Traditional networks struggle to meet these requirements because they rely on a static configuration and manual management. Whenever traffic patterns change, network performances can degrade due to congesting or insufficient routing. The SDN controller consistently monitoring traf- the traffic flow of network conditions. This helps in maintaining consistent quality of services even during high traffic loads. SDN also reduces human errors and simplifies network management. Therefore, SDN is essential in building scalability, efficient, and queues our networks. Quality of services queues in computer networks. Quality of services or queues refers to the ability of networks to provide different levels of services to different types of traffics. Not all the data in a network is equally important. For example, voices and video traffic require a low delay and a low packet loss, while file transfer can tolerate same delay. So queues help ensure that critical applications receive priority over less sensitive traffic. Important queues parameters include delay, throughput, packages loss, greater delay measures how long it takes for data to travel from source destination to throughput indicates how much data is successfully transmitted over a network. Packet loss shows reliability of a network, and jitter represents variation in delay in SDNs. Queues management becomes more effective because the controller can dynamically control traffic flows. This makes SDN as the ideal platform for queues testing performance analysis. Importance of network topology. Network topology refers to the way of network devices are connected to each other. It identifies the structure of the network, determines how data flows between nodes. Topology has directed impact on network performance, reliability, and scalability. A well-designed topology can reduce delay and improve the throughput. Linear topology overview. Linear topology is one of the simplest forms of network topology. In this topology, all network nodes are connected in a straight line. Each node is connected to only its immediate neighbors. It will connected to the immediate next ones. Data must pass through multiple intermediate nodes to reach its destination. Because of its delay increases as the number of nodes increases. A failure in one node can affect the entire network beyond that point. Linear topology is easy to implement and suitable for small or experimental networks. However, it is not ideal for large scale or high performance applications. Even the SDN controller, the physical limitations of linear topology affects queues. Tree topology overview. Tree topology is a hierarchical network structure that resembles an inverted tree. In this topology, there is a root node at the top and multiple levels of child nodes connected below it. Each node can have one parent and multiple children, which can help the organizing the efficiently. Tree topology is widely used in enterprise networks and data centers because of these capabilities. Traffic flows from higher level nodes to lower level nodes and organized in a manner. This structure makes routing decisions simpler and more effective. In SDN environment, the controller can easily manage traffic paths in a tree topology. However, failure of node near to root can affect a large portion of the internet. So it is well suited for queues based on a network on evolution. Next, mesh topology. Mesh topology is one of the most reliable and robust network structure. In this topology, nodes are interconnected with multiple paths between them. It means data can travel through different routes to search its destination. Greatly improves fault tolerance and reliability. Next, comparison of selected network topologies. Each network topology has unique performance characteristics that affects quality of services. Linear topology is simple but suffers from high delay and low reliability as the network grows. Tree topology provide better organization and scalability with moderate performance. Mesh topology offers multiple paths resulting in higher reliability and excellent performances in SDN environment. Centralized control helps optimize the traffic flow in all topologies. However, the physical structure of the topology still influences overall performance. By comparing these topologies, we can identify which design is suitable for specific network requirements. This comparison is important for applications that demand high queues. Understanding these differences helps network designers. Next, SDN based queues testing framework. The SDN based queues testing framework provides a controlled environment to analyze network performance. It consists of an SDN controller. The SDN controller manages the traffic flow and enforces queues policies. The performance metrics such as delays, throughputs, and packet loss are measured during testing. This frameworks allows researchers to test different topologies under identical conditions. It also helps in understanding how SDN improves chaos management. The framework is flexible, cost efficiency, and easy to modify. Therefore, it is widely used for SDN performance evaluations and researches. So, tools and technologies used. Several tools and technologies are used for these SDN network topologies. An SDN controller such as POX and RYU is used to control the network. OpenFlow protocol is used for communication between the controller and the switches. Performance matrices considered. To evaluate a network performances, several QoS matrices are considered. End-to-end delays measures how long data packs takes to reach their destinations. These matrices provide a complete view of network performance. Next, advantages of SDN for QoS management. SDN offers several advantages for managing quality and services. Centralized control simplifies network monitoring and managed management. This therefore SDN plays a key role in QoS based on networking. So applications of SDN and QoS testing. IoT and smart city networks benefits from this dynamic traffic management, and these applications highlight the importance of SDG. They demonstrate its role in moderate networking. Thus, SDN is widely adopted across industry. Conclusions and what is the future scope of this SDNs? In conclusion, SDN software defined network provides a powerful approach to modern network management. To performance of an SDN network depends heavily on the chosen network topologies. Through QoS testing, we can analyze the how different topologies perform. Linear topologies is simple but limited in performances, and the differences of other topology conditions, and the adaptive QoS mechanisms can future improve all the performances. Thank you, sir.